This video covers stacked to grouped bar chart. The structure of this video is as follows: the goal, visual code walkthrough, JavaScript console walkthrough, and the summary. Alright, let's get started. The goal. We look at the D3.js.org website stacked to grouped bars example. This example has an HTML form with event listeners attached to input radio buttons that switches the bar chart from a grouped bar chart to a stacked bar chart. Using the information we've covered thus far about D3 transitions, D3 and HTML forms, as well as the D3 stack layout, we will do a code walkthrough as well as reconstruct the chart right in the JavaScript console. Let's look at a short video of the chart in action. Let's take a close look at what we are going to be building in this video. When we reload the page, we see the bar chart originally set up as a stacked bar chart. Then, after a short delay, the chart becomes a grouped bar chart. On the screen, you can see two radio buttons, one with the label grouped and one with the label stacked. As the stacked bar chart became a grouped bar chart, the radio button switched to represent the actual chart that was being shown. Now that everything is loaded and done transitioning, we can click on the radio buttons to make the chart change. When I click on the stacked bar chart, the bars float off of the horizontal axis and then spread out to be stacked bars. When I click on the grouped bar chart, the bars shrink and then float down to the horizontal axis to form the grouped bar chart. When we do the example, we'll use slower transitions and less number of bars and layers so that it is easier to see the object constancy. This will allow us to follow the data across the two different types of views. Let's walk through the code to get a feel for how this data visualization is constructed. Visual code walkthrough. The document starts with the doctype meta character set and CSS styling. This is the standard HTML doctype, meta character set, and CSS styling for the D3 data visualization we are making. Next, we create an HTML form. This form has a radio input group with two options, grouped and stacked. You can see that the initial checked input is going to be the stacked radio button. We will later use D3 to attach event listeners to these two radio buttons. Next, we go into the JavaScript section of the document. First, we load the D3.js JavaScript library from the web. This uses the D3 code hosted by the D3.js.org website. Next, we go into the code that will create the stacked and grouped bar charts. The first part of the code is charged with creating variables that we will use for the rest of the visualization. The n equals 4 is the number of layers. Here you can see that there are 4 layers, 1, 2, 3, and 4. The m equals 58 is the number of samples per layer. Here you can see that there are 58 different samples. They show up on the x-axis as 0 to the number 57. Next, we create the D3 layout stack layout function /object. This is the same functionality we saw in the prior video. We will use this to convert our array of layers into an array where each object has an x, y, and y0. Next, we generate the layers and the data contained within each layer. This line of code does 3 different things. The first thing is construct an array of numbers from 0 to the n variable we set above. In this example, it will be an array of numbers going from 0 to 3, which is in total 4 numbers. The second thing is that for each one of these numbers, the code uses a map to call an anonymous function that returns the result of the bump layer function. The third thing is the calling of the bump layer function with the variable m, which was defined as 58 earlier. Scrolling down the page, we look for and find the bump layer function. This function generates an array of layers, where each layer is an array of objects. The number of objects per array layer is dictated by the number of samples per layer we want. In this case, we are using the number 58. The function takes in 2 arguments, the number of samples per layer and how much we want each layer object data point to be bumped by. This ensures that every time this function is called, it will create a nice layer that has a bumpy look to it because of the random bumps each sample in each layer receives. Let's look at the layer generation line again. Now we know that the bump layer function returns an array of m objects. Since this is being returned as part of the function being mapped, it means that we are passing an array of 4 arrays, which each holds 58 objects, to the stack function. The stack function will then go through all of the arrays and all of the objects in the arrays and generate a y0 for each layer object. We now have our data in the layers variable. We use the D3 stack layout to do some math in the background for us. The next line of code calculates the max y that the grouped bar chart will have. Here we use the D3 max function to go through the layers variable, and for every array in the layers array, it will return the application of the D3 max function of the specific array in the layers array. This second application will return the max y attribute of all the objects in each layer. The D3 max is done twice because we have a nested data source. That is, we have an array of data representing each layer, and then each layer has 58 objects. The reason we just get y is because the grouped bar chart rectangles all touch the x-axis, so we only have to look for the one that is the tallest. The next line of code calculates the max y that the stacked bar chart will have. Here again we use the D3 max functions to get the max height for any one of the stacked bars. What is different this time is that since the bars are stacked on top of each other, we have to get the maximum y0 plus y from all the objects in all the arrays. This max y0 plus y will represent the top rectangle and the tallest stacked bar of the stacked bar chart. Having both the max stacked bar y as well as the max grouped bar y will help us make sure that the data stays within the confines of the inner drawing space during transitions. The next 3 lines of code are the D3 margin convention. The next 3 lines of code define the D3 ordinal scale for the x-axis. Because we are dealing with 58 buckets for our grouped or stacked bars, an ordinal scale is used. This is defined in the .domain part of the code. D3.range m gives you an array of numbers from 0 to m-1. The range of the x-axis is defined as the width of the inner drawing space. The next 3 lines of code define the D3 linear scale for the y-axis. This code shows the domain going from 0 to y stack max. This means that we are going to be drawing the stacked bar chart first. The range is the height of the inner drawing space to 0. This is done because the y-axis is inverted in the SVG coordinate space. The next 3 lines of code define the color scale as a linear scale. This is counter to all of the examples we have covered thus far. We have mostly used the category color scales, which are ordinal. That is, buckets of things to buckets of colors. Here we are defining a domain that goes from 0 to n-1. N was defined as 4, so the domain will be the number line from 0 to 3. The range is going to be an HTML color going to another HTML color. Because this is a linear scale and D3 knows how to interpolate HTML colors, we can pass in any number into this color scale and have D3 interpolate the color for us. The next 5 lines of code define the x-axis function. Here we define the x-axis and pass into it the scale to use as well as all the other usual attributes. Note that the code after this is not the definition of the y-axis. For this example, we just leave the y-axis off of the chart. The next 5 lines of code define the SVG container and the inner drawing space based on the D3 margin convention. The next 5 lines are where we will bind the data from the layers to DOM elements. We do the normal D3 pattern. We select all a class of DOM elements called layer. We bind the data. We choose the enter selection, and then we append an SVG group element with class of layer to each element. We also give each layer a specific color based on the index and how it is scaled through the linear color function defined earlier. Then the next 7 lines take those DOM elements who have a class of layer and use the data bound to them to create SVG rectangles. Each layer will have an array of objects bound to the data attribute. This second application of the D3 pattern will create an SVG rectangle for each of those objects. The D3 pattern of select all, data, enter selection, and append are done. Then the x, y, width, and height of the rectangle are defined. The x is defined as the scaled x from the object bound to the rectangle. The y is defined as the height of the SVG inner drawing space. This is done so that the rectangles are now defined on the screen but do not show up. The width is defined as the x scale range band. The height is defined as 0. Both the y and height are defined so as to take up no space on the screen. This implies that shortly after this code, a transition will have to occur to the y and height attributes of the SVG rectangles. In fact, the transition comes immediately with the next 4 lines of code. Every rectangle in the rect selection will now receive a transition. The transition will be delayed by the index number multiplied by 10. This is what causes the left to right cascade of stacked bars to appear when the page is reloaded. Let's reload the page and take a look. You can see that the rectangles appear out of thin air from the left to the right. That they do so in order is because of the delay command being set up by the index number of the rectangles. Going back to the code, let's look at how the y and height of each rectangle is set up. The y is set up as the y0 plus y of the rectangle scaled through the y scaling function. The height is set up as the difference between y0 scaled through the y scaling function minus y0 plus y as scaled through the y scaling function. This is what we would expect for a stacked bar layout chart. The y is the top left corner of the rectangle, so it makes sense that it is a scaled y0 plus y. The height is just the difference between where the rectangle y0 is scaled and where the top of the rectangle y0 plus y is. Once this transition is done, we have the stacked bar chart layout complete. The next 4 lines of code create an SVG group element and call the axis function so that the x-axis is created and appears on the screen. The next line of code defines an event listener for every element in the selection of D3.selectAllInput. The elements in this selection will be the radio buttons from the HTML form, which means that every time a radio button has a change event, the event listener will call the function change. You may ask yourself, how can we define what occurs when the event is triggered, given that we haven't yet defined the function with the name of change? This is due to JavaScript function hoisting. Functions defined with the function keyword and not assigned to variables immediately are quote-unquote lifted to the top of the JavaScript code. So even though we haven't yet defined it, when the script runs, it will lift the function definition to the top so that when the event listener is defined, the change function will already be defined. We will cover this change function in a moment. Before that, we look at the next 3 lines of code. This uses the JavaScript window method that calls a function or evaluates an expression after a certain number of specified milliseconds. So in this case, we are defining a function that does the following. 1. It creates a selection of the input radio button where the input value is equal to grouped. 2. It sets the checked property to true for this input radio button. 3. It calls the change function on this element. After the function is defined, the code passes 2000 or 2 seconds so that the set timeout will wait 2 seconds and then call the function defined. This is what causes the chart to automatically go from a stacked bar chart to a grouped bar chart when the page is reloaded. Let's reload the page and take a look. You can see the stacked bar chart appear from left to right. Then, after a 2-second delay, the chart transitions into a grouped bar chart. This is being driven by the set timeout functionality. Going back to the code, the next 5 lines of code are where the change function is defined. Because the function is not assigned to a variable, this function will get hoisted. The first thing the code does is to clear the timeout to make sure that there is no timeout code still waiting to be run. Then the code, through a conditional statement, checks to see if the element that received a change event has a value of grouped or something else. The something else in this example is stacked. If the value is grouped, then it will run the transition grouped function. If it is something else, then it will run the transition stacked function. This is where and how we control what happens each time the HTML form radio buttons register a change event. The rest of the code is used to define the 2 transition functions. Let's look at the transition grouped function first. Again, because the function is not assigned to a variable, this function will get hoisted. The first thing the code does is to redefine the domain of the y scale. This is because this function is triggered when the chart is currently in its stacked form. So we need to redefine what the max y is for the y-scale function domain. Next, we define the first of two transitions for the rectangle selection. Next, we define the first of two transitions for the rectangle's selection. For the first transition, we define the following properties: a duration of 500 milliseconds, and a delay of 10 times the index of the element in the selection. As we saw earlier, this will cause a cascade from left to right. Then we define the attributes we are changing in this specific transition. First, we change the x of the rectangles. We are moving from a stacked bar chart to a grouped bar chart. So instead of the bars for a sample being stacked up on top of each other, they need to sit side by side. The math to do this is as follows. First, we take the x scale of the x for the element. This is going to be the same for all the rectangles in the stack because they are stacked. Then to each x, we add the range bandwidth of the x scale divided by the number of layers multiplied by j. This j is something we haven't covered before. The j is another variable that is made available to us by D3. The j is the index of the nested data we are in. In terms of layers, this will be the layer number. If we think back to the layers variable, it was an array of 4 arrays. Each internal array then had 58 objects. A selection of the internal array objects uses the letter I to indicate the index of each object within an array. A selection of the internal array objects could also use the letter J to indicate the index of the parent array in the array of arrays. This formula makes it so that each x will now be defined in a way that makes it so that none of the x's overlap with each other. Second, we change the width of the rectangles. This is defined as the range bandwidth of the x scale divided by the number of layers. After having defined the x's so that they don't overlap, the width definition makes it so that the rectangles go from edge to edge but still don't overlap. Next, we define the second of two transitions for the rectangle selection. This transition has no delay or duration, which means it occurs immediately and takes 250 milliseconds to complete. Two attributes are changed in this transition. 1. The y of each rectangle is defined as the y-scaled y from the name value pairs the object has. 2. The height is defined as the height of the SVG drawing space minus the y-scaled y. This is computed in this way because all of the rectangles will now start at the x-axis and go up. Once this is done, the transition from a stacked bar chart to a grouped bar chart will be complete. Now, we look at the transition stacked function. Again, because the function is not assigned to a variable, this function will get hoisted. The first thing the code does is to redefine the domain of the y-scale. This is because this function is triggered when the chart is currently in its group form. So we need to redefine what the max y is for the y-scale function domain. Next, we define the first of two transitions for the rectangle selection. For the first transition, we define the following properties: a duration of 500 milliseconds, and a delay of 10 times the index of the element in the selection. As we saw earlier, this will cause a cascade from the left side to the right side. Then we define the rectangle attributes we are changing with this transition. First, we change the y of the rectangles. We make the new y attribute the y scaling of y0 plus y. Remember, we are transitioning to a stacked bar chart, so the y needs to be the baseline plus the height of the rectangle. Then we make the height of the layer y scaled y0 minus the sum of y scaled y0 plus y. This will give us the height of the rectangle in y scaled terms. Overall, this first transition brings up the rectangles off of the x-axis so that they can then be slotted on top of each other. Next, we define the second of the two transitions for the rectangle selection. This transition has no delay or duration, which means it occurs immediately and takes 250 milliseconds to complete. Two attributes are changed in this transition. 1. The x of each rectangle is defined as the x of the object. This is so that all of the rectangles in a stack will start at the same x coordinate. 2. The width of each rectangle is defined as the x range band width. This is so that all of the rectangles in the stack will have the same width. This will make it so that all the rectangles are stacked neatly on top of each other. And with that, we have covered the visual code walkthrough. Next, we will build the chart section by section in the JavaScript console to get a feel for how it works. JavaScript console walkthrough. From the example page, we click on the Open a New Window link. This takes us to the raw example. This is where we will recreate the chart section by section using chunks of code to get a feel for how it works. The first thing we do is open up the Chrome Developer Tools. We will use the tools to delete the chart that has already been created. We will also use the tools to create the new chart. Let's delete the SVG that was created so that we can start fresh on this page. In the Chrome Developer Tools, you can click on a DOM element in the Element section and delete it by pressing the Delete key. We now have a clean slate. Note that we left the HTML form with the two radio buttons intact. Because we are just redoing the graph in D3 and JavaScript, we do not need to remove and then re-add the HTML form. When we click on the radio buttons, nothing happens. All we did was delete the SVG elements from the page. So as the radio button still exists, the event listeners will still exist. However, since there are no SVG objects to transition, the radio buttons don't do anything. Let's scroll right and start the chart construction. Because we are constructing the full chart in the JavaScript console, we will not be able to take advantage of JavaScript function hoisting, which means that we will have to define all of the functions first and then go through the creation of the data visualization. First, let's define the bump layer function. This will be used to create our data set. Next, we define the transition grouped function. This function will cause two transitions to occur when the graph is switched from a stacked bar chart to a grouped bar chart. Note that for the first section of the transition, we changed the duration from 500 milliseconds to 3000 milliseconds. And for the second part of the transition, we added a duration of 3000 milliseconds. This is so that we can see what is really happening in slow motion. Next, we define the transition stacked function. This function will cause two transitions to occur when the graph is switched from a grouped bar chart to a stacked bar chart. Note that for the first section of the transition, we changed the duration from 500 milliseconds to 3000 milliseconds. And for the second part of the transition, we added a duration of 3000 milliseconds. This is so that we can see what is really happening in slow motion. Next, we define the change function. This function will figure out which radio button was selected and then call the right function to cause the correct SVG transitions. Alright, we now have all the functions defined that we are going to use. Let's start the construction of the data visualization. We start by defining the variables. The first variable we define is the number of layers. We leave the number of layers the same as the D3.js.org example. The next variable we define is the number of samples per layer. Rather than the 58 in the example, we are going to use 3. This will allow us to really pay attention to and understand what is happening to each group/stack of bars. Next, we define the D3 stack layout. Next, using the D3 stack layout and the bump layer function defined earlier, we create the data for the chart. As expected, because we asked for 4 layers, we got an array of 4 arrays. Each of the 4 arrays then has 3 elements. Also as expected, because we asked for 3 samples per layer, each of the 4 arrays has 3 JavaScript objects inside. When we click into the first 2 arrays and then click into the first object of each array, you can see the X, Y, and Y0 of each object. True to form, since we have passed the data into the D3 stack layout, you can see that the Y0 is calculated correctly for us. Next, we figure out the grouped bar chart max Y. Note that this number is not yet scaled, so it looks smaller than expected. Next, we figure out the stacked bar chart max Y. Again, this number is not yet scaled, so it looks smaller than expected. What is good to note is that this number is bigger than the Y group max. This should make sense, as the stacked bar chart should be taller than any one of the individual bars in the grouped bar chart. Next, we use the D3 margin convention to define the SVG container and inner drawing space height and width boundaries. Note that because we have the Chrome Developer Tools open, the chart will not be fully visible until the end when we close the Chrome Developer Tools. Next, we define the X scaling function. Next, we define the Y scaling function. Next, we define the linear color scale. Next, we define the X-axis using the X scaling function and orient the axis at the bottom. So far, so good. Now we start creating and placing visual elements on the inner drawing space. We start by creating the SVG viewport and inner drawing space. Next, we create the layers based on the layers data variable. We can see the 4 new SVG group elements with class of layer. Each of these G elements will have an array filled with objects. Let's look at the first G element with class array to see the data attribute. We can see that the data attribute has an array of 3 objects. When we click into the object, we can see the X, Y, and Y0. In the next set of code, we will use this array of data. Next, we create rectangles based on each of the layers' internal array of objects. You can see that each SVG group element with a class of layer now has 3 rectangles inside of it. However, you can't see the rectangles because we set the height to 0 and the Y to be the height of the inner drawing space. Next, let's perform a transition to change the height and Y of these rectangles. Note that we multiplied the index by 2000 instead of 10 to make sure we were able to see what was happening in slow motion. We saw the rectangles appear from the left to the right of the screen. Next, let's create and place the x-axis on the chart. Remember that the x-axis has to be translated to the bottom of the inner drawing space. Also, remember that the array of samples is 0 based, so the first number under the first set of bars is 0. Next, let's define and add event listeners to the HTML form radio button elements. This will allow us to play around with the transitions. Lastly, let's add and define the timeout variable. This makes it so that we can see the transitions happen at least once by themselves before we have to manually click on the radio input elements. Fantastic, we are done with the code. Let's close the Chrome Developer Tools and see the transitions in action. Notice that by having the transition animations happen in slow motion, we get a much better understanding of why and how the transition math works for the x-coordinate and y-coordinate, as well as the height and width of each rectangle. Also notice that regardless of whether we are in the grouped bar chart or stacked bar chart data representation, that the tallest bar goes to the top of the inner drawing space. The reason for this is that we obtained the max grouped y and max stacked y, so that we could change the y scaling function in each transition. As a final note, let's talk about a concept called object constancy. As the representation of the data changes, though we can see the object representing the data being transformed, we are able to follow an individual data object from one visual representation to another. This is very important when you are working with transitions and animations. You wouldn't want to lose people, right? And with that, we have covered using the information from all prior videos to create a dynamic data visualization which allows the user to change the representation of the data from a stacked bar chart to a grouped bar chart. We use HTML form radio buttons, the D3 stack layout, and various transitions to change from one representation to another. The summary. This video covered the goal, visual code walkthrough, JavaScript console walkthrough, and the summary.